Welcome to the class 14 of the lecture How to Rotate About Accurate Pivot Points in UE4 C++. Let's open the project Robot Tutorial 1. At the beginning of the lectures, let's introduce a concept, TCP points of robot. What is TCP points? You can say these as tour center point or tour contact points. The TCP points at the mini machines is at the center of the tour. But at the robots, it could be anywhere. It could be the center of the tour or any other places. If we saw tour here, the TCP points located at the pivot point of the 6th joint. Use the red arrow define the x direction, the y arrow to show the y direction, and the blue arrow to show the z direction of the TCP points. If with tools, the TCP points will influenced by 6 operation, which is x, y, z, 3 translation matrix, and A, B, C rotate about x, rotate about y, rotating about z axis, 3 matrix operations. After these 6 matrix operations, the TCP points will shift to the center to a tip and incline the red arrows point to this direction, the y arrow point to that direction, the z arrow point to another direction. Since in UE4 the x arrow is pointing to the different way as the usual right hand coordinates. If we show the red arrows at these points will point inside the robot, we cannot see the red arrows. So from now on, we'll turn the x-axis 180 degrees to let the red arrow point outside direction, and the green arrow point that side, the blue arrow point to the sky. We prepared RGB arrows at SolidWorks at a home position. Right now, use Data Smith to translate the XORG as red arrows, YORG the green arrows, the ZORG the blue arrows. The first XORG.IGS located at geometry. OK. Import. And merge these 2 lines by using developing tools by picking merge actors. Pick Qling and replace, and press merge actors located at the geometry. The file name give SORG. Save. Cross. You see the red arrow point to the right opposite direction with the original X direction of UE4. Next, use DataSmith to translate yorg.igs located at geometry. OK. Import. Develop tools. Merge actors. Merge actors located at geometry. The file named yorg. Save. Cross the green arrow. And the zorg.igs located at geometry. OK. Import. Window. Develop tools. Merge actors. Merge actors located at the geometry folder. The file name zorg. Save. Cross. After the RGB arrows prepared at home position, but you cannot see RGB arrows because hidden by the robot body. Okay, now let's open the Visual Studio C++ program. First, let's alter the program about the hierarchy structure. We'll remove the tool into robot rotation.header. At the previous lectures, we defined fn1, fn0, fn1, fn2, then static mesh, fn6, and the tool fnt. Right now, we will remove the tool simply using // to mark line out, and by using copy methods to copy these two lines, and Control V, your property bracket, add anywhere bracket, your static mesh component start to generate the XORG semicolon, and then duplicate these two lines under by using Control V to generate YORG, and then Control V to generate ZORG, and then back to .cpp, add a constructor. You see in the constructor, the root component equal to root, fn0 attached to root, fn1 attached to fn0, until fn6 attached to fn5, fnt attached to Fn6. Right now, no tools, so use double slash to remove this line and this line. By using copy these two lines under here, Control V, divide SORG equal to create default sub-object smaller your static mesh component greater bracket text bracket quotation SORG quotation bracket semicolon SORG minus greater attached to bracket Fn6 bracket semicolon. And Control V, YORG equal to create default sub-object smaller your static mesh component greater bracket text bracket quotation YORG quotation bracket semicolon YORG smaller greater attached to bracket Fn6 bracket semicolon. Control V, ZORG equal to create default sub-object smaller your static mesh component greater bracket text quotation ZORG quotation bracket semicolon ZORG minus greater attached to bracket Fn6 bracket semicolon. Control Shift B to compile this program. After compiling success, the C++ will alter the UE4 editor's right side of the display panel. You will see no more about the tool, geometry, or the hierarchy position. Instead, at hierarchy, at component position, you will see SORG, YORG, ZORG availables. Then we can give the geometry model of these three static mesh. To generate the current hierarchy geometry model. Okay, success. Back to UE4. You will see. Press robot rotation 1. Down here, under Fn6, there isn't Fnt. Instead, SORG, YORG, ZORG showing below. Pressing SORG, static mesh. Press this triangle to pick SORG geometry. Static mesh. SORG, the first one. the red arrows showing at the static mesh this small window, and here showing as well, but we cannot see because hidden by the body of the robot. Next, YORG. Pick YORG, the green arrows, and then ZORG, the blue arrows. Okay, after the hierarchy structure geometry model available, let's go inside the program to change something. First, add a tick, use / to remove RGS6 settings. This is for testing. At last lecture. Okay, inside robot pose, after join number 1 matrix operation, join number 2, rotating about the pivot points, and join number 3, 4, 5, 6. Join number 6. There isn't any calculation about the tool because the tool is a static mesh located at the pivot point of 6 joint number already, so there's no calculation at all. But RGB arrows located at home positions, we have to rate these 3 arrows located as tool actually located at the 6 pivot points positions. We need to use set relative location at the location of pivot point 6 XYZ. So in here we copy this line, and under here Control V to define SORG minus greater set relative location bracket F vector bracket. The X is the pivot point of X. The first argument is pivot location dot X, comma. The second one is pivot location dot Y. The third is Z, the pivot location dot Z. Okay, then copy this line, Control V to define the Y ORG, the green arrow, minus greater set relative location bracket F vector bracket pivot location dot X, comma, pivot location dot Y, comma, pivot location dot Z bracket semicolon. Rotating about the same pivot points. The last one, Control V, the ZORG, smaller, minus greater set relative location bracket f vector bracket pivot location dot x, comma pivot location dot y, comma pivot location dot z, bracket semicolon. Control Shift B to compile to see the alteration, correct or not. After compiling success, okay, success, back to UE4, you will see the RGB arrow showing at here. The set relative location will shift RGB arrow from 000 position to the 6th, join number 6 pivot points at here to show the TCP points at the home position. Okay. By using press play, you see the red arrow pointing to us is X direction. The green arrow pointing to the right is the Y direction. The blue arrow pointing to the sky, which is the Z direction. Okay. These 3 RGB arrows define the home positions TCP points. This is the end of lecture 14. Thanks for watching. Bye bye.